CSI 2140 Analyze Mode Impact Test Hammer plus up to 3 vibration channels. My name is Johan van Pijnbroek, and in this video tutorial I will show you how to use the CSI 2140 machinery health analyzer to perform impact testing, where one channel will be an impact hammer and up till 3 vibration sensors can be used to measure the response. What you are seeing now in front of you is a home screen of the CSI 2140 machinery health analyzer. If you want to perform impact test, go to F7 Advanced Analyze, go to F1 Manual Analyze and set Analyze Mode, select Impact from the list. In F2 you can specify your frequency range and your number of resolution lines. I will use the default from 0 till 1000 Hz with 800 lines of resolution. F3 set average. Here you can specify how many averages you want to use. I will accept the default value of 4. F4 set window. Here you can specify the window, and what you're seeing here, an exponential window, is typical for impact tests. Text setup is not applicable here, so we can ignore it. Set trigger. This is very important because that means that the data collector will be in a wait mode, and as soon as he feels an impact, he will consider the impact as the impact from the hammer, and that will trigger the data collection. Now there is a pre-trigger of 10%. That means from the total window that will be measured, the time window, 10% will be displayed before the event, before the impact. The trigger level is default set to 22 Newton. A general guideline here is that if the data acquisition is already starting without impacting the installation, that means that there is some background vibration that is bigger than the 22, and the system recognize it as an impact hammer pulse, and that is of course wrong. So if data collection starts without striking with the hammer, you have to increase the level here. You can also have the opposite situation. If the structure is very rigid and you impact it, but you are not able to input sufficient energy with the hammer inside the system, you may have to reduce the level here. But for most applications the default value will work fine. So if you have to change it, go to F9 set trigger, and here you can change the pre-trigger and the trigger level. Very important to verify here is the input. So I go to F12 input setup, and in this example select input. As you can see, I've activated the 4 channels, and in the sensor setup, input A and B are accelerometers, C also, but channel D is my impact hammer. One last thing before we can start taking measurement. In plot setup F6, on the left side you specify here what you want to see after data collection. On the right side you can specify what you want to see during data collection. As you know, there is a maximum of 4 plots available simultaneously, so 4 plots to display, but in reality there are far more than 4 plots. So if you want to change those 4 plots here, you prefer to see something different after data collection, you can change it. One example is set plot type 1, click on F2, and you can choose from the list what you want to see. So the options are the waveform or the spectrum from the reference, the waveform or the spectrum from the response, the coherence plot, the phase plot, and then the 2 transfer plots, reference divided by response or response divided by reference. So here you configure what your default screen will look like after data collection, and you can change the format between stack or quad. During data collection you can choose what you want to see here, and now it's set to the waveform of the reference, so you will see the waveform of the impact and the 3 coherence plots. If you prefer something different during the live, change it here, set plot type, and the list of options are: I want to see the 4 waveforms, or I want to see the 4 spectra, or I want to see the reference waveform plus the 3 coherence plots, or plus the 3 phase plots, or plus the 2 kinds of transfer functions. In this example, I will use the reference waveform plus the coherence plots. And now I'm ready to collect data. As soon as you push enter, data collection will start, and the data collector is telling you strike with force hammer, so I will now impact the installation. And the first average is done, and you see here the waveform of the impact and the 3 coherence plots. Now he's asking you to repeat it 4 times, so I have to strike 3 more times. Second one, third one, and last one, and data collection is done. A few explanations here. At the bottom you see the transfer functions, here the coherence plot, here the phase plot, and here the response spectrum. So you see immediately here is a natural frequency in the A direction of my sensor. If you go to next response input, you can toggle between. Now it's B versus D, C versus D, or once again A versus D. If you go to switch plot type, F6, here you can change if you want to see something different. For example, if you want to see also the waveform of the response, and now you have the response waveform, the coherence, the phase, and the response spectrum. With F5 change active plot, you can change the red box, and the red box is always your active plot, and in the active plot you can install a cursor and read out immediately the natural frequencies. All this data can be stored inside the job mode by pushing F9 and store it in a job. We are now at the end of this video tutorial. Please visit our website at www.assetweb.com/mhm for other video tutorials and product information. My name is Johan van Pijnbroek. Thank you for watching this video tutorial.